In this tutorial, we will simulate the dynamics of a simple two-gene regulatory network using a function nanoservice. The related course materials are shown in orange in the slide. In case you do not have a Microsoft Azure account, please watch Creating a Free Azure Account in the playlist. There are two players in this tutorial. One is client and the other one is a server. So client is a web service consumer and the server is web service provider. For client, we use a Jupyter Notebook and the language we use is Python. And on the server side, we use Azure Functions, which is a Nanoservice provided by Microsoft Azure, and Azure Platform to write code. And the language that we use is C#. The client basically consumes difference equation service provided by the server, sends p sub xy, p sub y, current x, and current y values to the server, and receives next y. On the other hand, the server provides difference equation service, receives p sub xy, p sub y, current x, and current y values, and most importantly, computes and returns next y. As you can see, the client code uses Python language and the server code uses C#. And these two different languages can talk to each other thanks to RESTful Web Service Protocol, which enables interoperability. If you want to know more about Azure Function, you can Google Azure Function. Click this one. This page introduces Azure Function. And since we want to create Azure Function using Azure Portal, let me type Azure Function Portal. And this is the document that we want. As you can see here, there are many ways to create Azure Function. You can use Visual Studio Code. You can use even Python to create Azure Function. But in this tutorial, we're going to use Azure Portal to create function. So what I'm going to do now is go through these steps and show you how to create Azure Function that provides difference equation service to simulate simple two-gene regulatory network dynamics. Now let us create an Azure Function using the Azure Portal. So let me type in Azure Portal and click this link, click sign in. I need to type in my Azure account email and the password, and then I click sign in. Okay, now I'm here. Let me click this one, create a resource, and I will search for function and click enter. Then here we have this function app, and I will click that and click create. Here you need to give a name for your function app. By the way, function app is a collection of functions. And then subscription free trial. There is no other option. Resource group. So Azure has many services and resources. So you can group them together to efficiently manage them. In this case, I will just create a resource group named Yongjun 3. And OS, Windows, which is okay. And hosting plan, consumption plan. And location, let's choose East US because this is where I am right now. Runtime stack, .NET, which is okay. Storage, create new, and this is the name for that storage. Application site. Okay, so now I click create, and then here we see that deployment is in progress. You might need to wait a couple of minutes. Now it says deployment succeeded. You can click this go to resource, or you can click resource groups. And now I see this resource group, Yongjun 3, I just created. So let me click that. Here I see 4 resources grouped together. And I want to click this one, which is function app. Now I want to create a new function. So let me click this plus sign. And here we have different ways of creating a function, but for this tutorial, I will use this importer editor. So let me click that and click continue, click more templates and finish and view templates. Now you see a bunch of different templates available, and let me click this HTTP trigger, and I need to give a name for this new function. So let's call it simple to gene regulatory network service. It's a long name. Here I select anonymous, which means that no authorization is required. Anybody can access this service. I click create. So here now we have Azure function created. This part is just one function. The function has this name run, which you don't change. What I'm going to do now is make some changes to this code. So first I'm going to change this to double because the variable that we will be returning to the client has this type double. That's why we have double here. And let me erase these two lines. And we want to leave these two lines as they are. And let me erase also the rest. And here I'm going to type double x equals data dot x semicolon. And this represents X protein. Note that this is not a vector but scalar. This variable has all the data received from the client. And from that data package, I extract this X variable, and that is represented by this notation, data.x. Now, I have a second variable, again type double, and it's data.y. By the way, this double means it's a double precision floating point format that uses 64 bits to represent a number. So this is Y protein. Again, it's a scalar value. And we have production parameter p sub xy, data dot p sub xy. And we have p sub y, which is degradation parameter. And now we have the difference equation. Y is equal to pxy times x plus p sub y times y. This x and this y are the ones that we receive from the client. So you can consider these x and y as previous x and y. And this y is a new y that we want to return to the client. So next line will be return y. So we will return new y value to the client. Let us save this. And the next thing we want to do is get function URL. So this is a service address. And let me click this and you see this URL, and I will copy that and close this. Now let me go to this client-side code that I wrote using Google Jupyter Notebook or Collaboratory. Actually, this code is very similar to the one that we saw before to simulate simple two-gene regulatory network dynamics. Here we are importing some libraries. The new package that we are importing is this one, request, which is needed to communicate with the server using RESTful web service. And this part is actually identical, so I'm not going to explain this part here. This is the URL that I copied from Azure Function. And here we have the for loop. And we have this data variable, which is defined as this. So it's basically a collection of 4 variables, x, y, pxy, and py. So pxy and py are parameter values defined here. So it's 0.2 and 0.9. xi minus 1. So what is this value when I is 1? 1 minus 1 is 0. So x of 0 is 10 because we are assuming constant X protein values and the constant value is 10. Here, y of 0 is this one. So the initial Y protein concentration is 0. So we have this X value 10, Y value 0, PXY 0.2, and PY 0.9. Okay, so that's the data variable. And we send that data in JSON format to this URL, which is shown here. And we use this RESTful web service command post. After we make this service request, we receive a response, which is new Y protein value. And we convert that into JSON, into a JSON format. And we store that value in this Y of I. And I just print that Y of I to see that whether I'm getting the right value or not. And this part is just for plotting. I will explain this part later. Now, let me run this code. And you see that we are getting some numbers. And at the end, we have this plot. So let's go back to the server. If you click this logs, it seems like it's not responding. In this case, you might want to refresh. And then let's go to function and then click this and logs. Okay, so I will run the code again. So I will run it. Now you see all these blue lines. What's happening is at each iteration or at each loop, this Azure function Nanoservice is triggered and successful. You can actually print out something into logs window by using this command. So let's say I want to print out new Y protein value. So I say log information, and then I say $, the new Y protein concentration is curly brace, Y curly brace. Okay, let us save this and execute this code again. We are running the code and let's see the log file. Now you see that the new Y protein concentration is 19.98 something. And you have another line that says the new Y protein concentration is 19.9887 something, and so on. So now we see that these new Y protein values are printed out in the logs window. Now, what if you want to return not a single value like Y protein concentration, but multiple values? Let me show you how to do that. So first, we need to create a new class called a response. And we have public double X, which is X protein concentration, and public double Y, which is Y protein concentration. So now, because we are returning this class type, we need to change this. We are not returning double, but returning response type that we just created. So we change that to response. We are not returning Y, so let me comment this out. And we make an instance of this class response. We call that instance or an object R is new response, and this r.x. So as you can see here, we have two variables for response, right? So first variable x, r.x is equal to x. So this x comes from here, and semicolon, and we have r.y, which is also y, and this y is this one. Then we say return r. So we are returning this response type variable r to the client. Let us first save this. This is our response. So we get the response from the server and store that here. Let's comment this out, and let's comment this out as well. We have this new variable response in JSON. We convert this response into a JSON format. Let us print that JSON data, and from this JSON data, we extract this Y variable and we assign that value to Y of I. And let's run this code and see what happens. So I will run it. And now you see that we have both X and Y values printed out. And let's scroll down, and at the end we get this plot.